Welcome. Today we're going to talk about mcpgraphToolkit. If you haven't seen the mcpgraph video or read any of the documentation, it might make some sense to look at that to give a little more context. I'm going to go ahead and jump in. So we're going to talk about mcpgraphToolkit, which is a set of skills and tooling to allow agents to orchestrate MCP tools via mcpgraph. So let's first start talking about code mode. Again, I'm just going to touch this very briefly. I've gone into a lot more detail in other places, but essentially a couple months ago, Cloudflare, Anthropic, and Docker, within a short period of time, all released different papers and solutions around this thing they call code mode. And it's based on some academic research done about a year before that showed that agents and LLMs are actually pretty good at writing code to solve problems that they can't really otherwise solve through inference very easily. And this is an expansion of that. So it's essentially saying of the specific problem of trying to orchestrate MCP tooling to call multiple MCP tools in sequence, for example, that agents are actually a lot better at writing code to do that than they are at doing that themselves. And there's some other advantages to doing that in terms of saving context and improving accuracy of how the agents actually operate. So it's generally a system where the agents are, instead of doing a series of calls to MCP servers, they're writing some code that presents as an MCP server that orchestrates calls to other MCP tools. But how does it work really? So that's the question. In all three of these papers and in the code that's behind them, and I'm willing to just go ahead and allow that this works. I mean, I believe that these agents are capable of writing MCP servers in these languages and building wrappers, and the whole thing actually functions. So that's not really in debate. And they give enough artifacts and tooling to sort of show that they've actually done it successfully in all three of those cases. But they don't. None of them really give you like an end-to-end description of all the tooling that was required to make the whole solution work. There's no live demo. There's no like repo that you can reproduce it in. And so it immediately caused me to have this question of like, well, how did you have to prompt the agent to build those code mode MCP servers? Because you can't just say, go build an MCP server. Like, it's going to need a lot more information than that. And I played with doing that a little bit. And the agent needs to understand a bunch of things in order to do this process, right? It needs to understand which MCP servers it has access to and how they're configured. And agents typically don't understand that. They don't even understand how their own MCP tools come from servers and how they're configured. And the servers you might want to use might not be the same set the agent has. The agents need to know how to structure and where to place these artifacts and just sort of the general strategy to build them. They need some kind of testing tools to validate that these things actually work. And I've seen them struggle with that. And then finally, they need a way to install the MCP server into their own environment and actually run it. So even if the agents can build these tools, which I'm sure they can, how do those tools then magically sort of show up in the agent environment so they can run it? So if you're building your own agent tooling, it's probably more straightforward. But if you're just using a coding agent like Claude Code and you want it to be able to build these kinds of tools, it's not entirely clear how these code mode solutions would actually do that. Maybe they can, but it's not really clear from the information that's been given. So let's shift gears a little bit and talk about our own solution, mcpGraph, which is a no-code solution to this sort of code mode problem. And again, I'm not going to go into a ton of detail because I've done that in other videos and documents. But mcpGraph is basically a domain-specific language for MCP tool aggregation and orchestration. So it's a declarative configuration in a YAML file where you can essentially make a YAML file that says, hey, I'm implementing this MCP server. It has a bunch of tools, and each of those tools are implemented in a graph, which is a series of nodes. And those nodes can do things like call other MCP tools. They can do data transformation, extraction, conditional logic. So you basically have this nice, static, observable graph that you can execute to do fairly sophisticated tool orchestration. And there's no embedded coding language, so it's totally safe. So again, I'm not going to go into a ton of detail, but it's essentially I can build a YAML file. I can run this mcpGraph server to expose tools from that YAML file to an agent, which can then run those tools. And those tools are run as graphs, directed graphs. So how do agents actually build with mcpGraph? So this is the first thing we started playing with. We built an agent skill, a skill.md file that had detailed documentation of the mcpGraph format and the MCP server itself. And we gave that skill and the mcpGraph server to an agent. And we started prompting it to go build graphs, to go say like, hey, go use these, this set of tools and build another tool that does, some new thing. And what we found was it took a lot of prompting, including very detailed prompting, including specifically like which MCP servers to use and exactly how to configure them and where to put things. It took a lot of handholding to get it to the point where agents could actually build working graphs. But we got to that point. But we saw the agents struggled with the tooling, or I guess lack of tooling. And again, I think this problem sort of exists in all the code mode things, but once you've built one of these things, then how do you actually test and evaluate and debug it and make sure it works correctly? And agents don't necessarily have tools for that. I've seen them try to make tools. I've seen like agents try to go figure out ways to run shell scripts that'll run code that it wrote to be an MCP client to try to test them with varying degrees of success. And there's just a lot of variability depending on the complexity of the task, the complexity of the server that we're asking it to write, the graph we're asking it to build, and particularly around the quality of the MCP servers. A lot of MCP servers, especially sort of the common ones used by developers, don't have very good consistent output documentation. So their output schema of what the tool actually returned is often incomplete. Oftentimes it's not structured output, it's just text output, and there's no indication from the tool description of how that text is going to be formatted. So there are a lot of cases where you can't even really write one of these things, even as a human developer, without actually testing the server and seeing what the output looks like and being able to do a few rounds of that. So they definitely struggle with that quite a bit. And so we thought, well, okay, this is not ideal. The whole point of this was we wanted to demonstrate that the agents could build these graphs and then they could run these graphs and problem solve. We have sort of an end-to-end code mode solution with no code, and it didn't work great. So then we started thinking about, well, watching the agents struggle, and this is the nice thing about the agents being text mode AI agents like Claude Code, you can sort of see their whole thought process. You can see everything they try and all the dead ends they run into. And we started to notice some patterns. And I think the big aha moment was, look, these agents need some tooling, just like a human developer would, that will allow them to actually do some iterative development of these things. So in addition to like all the knowledge, they also need some tooling. So we built this tooling called mcpgraphToolkit, which is basically a development environment for the agent to build MCP graphs. It allows the agent to inspect the graph, see what graph tools there are, add, update, and remove tools. It can understand the MCP servers that are available to the graph tools. It can test the various building blocks, so it can actually call an MCP tool directly. It can test JSON data or JSON logic or sort of data transformation, extraction, decision-making expressions. Those can get complex, so it can test those individually. It can actually test the graph tool without deploying it, so it can give the whole graph tool. It can specify that it wants logging, so you'll get like a complete execution history, all the console logging, and detailed error messages. So this is what a human developer would have access to if they were running this. They'd be able to see their console and have that information. We allow them to deploy graph tools and then run those deployed graph tools. So we have a complete end-to-end environment where the agent can sort of plan, design, test, build an MCP graph, and then when it's done, it actually deploys it, and then it can just run that thing. It's available now in the context of that agent. It can run it whenever you need it to. So that's sort of the dream of the end-to-end code mode, but we're doing it without code with MCP Graph. So now when agents build with mcpgraphToolkit, it's similar development environment. We have a SKILL.md that's a little bit different than the other one because this agent skill is now directed at the agent interacting with mcpgraphToolkit. So we removed a little bit of information about things that it doesn't really need to know about how the graphs work anymore. And we doubled down on the actual tools in the toolkit and how to use those. And then we give it the mcpgraphToolkit server that's installed on an empty graph so that it can build and deploy and run tools on it. And then we went through a whole series of DevRel cycles where we basically gave it a prompt and told it to build a tool or a few different tools based on that configuration. And we watched where it struggled, and it probably took half a dozen times through this to get to something that was pretty clean. But we noticed lots of things. One of the big things was that it struggled with understanding the MCP server output, which is something we sort of anticipated. And this is one of the nice things. Like we actually asked Claude, "Hey, where did you struggle, and what could we have done in the API or in the documentation to make it easier for you?" And we got really good feedback. So we went through a bunch of cycles. We made a bunch of changes to the API, some additions to the API. And we finally ended up at a spot relatively quickly where we had a pretty close to 100% success rate. Like we haven't tried super complicated scenarios, but I haven't seen anything fail. All of our test vectors succeed 100% of the time with very few wrong turns, almost no wrong turns, meaning that you can see the agent basically, reason about the problem, read the skills documentation, see what tools it has available, get more details about the relevant tools, and then start testing sort of the building blocks and eventually assembling it, testing the graph tool itself, and then deploying the graph tool. So we can sort of see that whole process and see that it runs pretty cleanly. And so the agents can now build and run these tools on demand. And then those tools, once they're run and deployed, they're available going forward. So you can, within the same session or in subsequent sessions, you can just say, "Hey, go run that tool that you built," and it'll be able to run it without having to do anything else, anything special. So we're going to do a demo in Claude Code. And I'll make the point, this is sort of if you want to play with it yourself, there in the MCP Graph repo, there's a directory called Test Claude, and that's a complete Claude Code project with all the configuration you need. Like literally, if you npm install MCP Graph and then you go to the Test Claude directory in this repo and you just run Claude, you can start building tools on the file system and and fetch MCP servers with no additional configuration. So we basically pre-installed the skill, the agent skill. We pre-installed the mcpGraph toolkit. We pre-approved the skill and all the toolkit tools, and we've given the fetch and file system MCP server to the toolkit. So all that stuff is basically just ready to go, which I'm going to show you in the demo. But if you were to run this yourself, it would perform exactly the way I'm going to show you right now. And then as a prompt example, this is the one we're actually going to use. Create an mcpGraph tool to download a URL to a local file in the downloads directory of this project and return the file name and size. So that's the prompt we're going to start with. So let me just give you just a brief overview of sort of what this looks like. This test Claude directory is the Claude Code directory. So it has a skills directory with the mcpGraph toolkit and the skill there. You can just copy this file into this directory in this structure in the .claude folder in any Claude Code project, or you can do it at the Claude Code higher level. Or you can use the Claude Code installer to install it and point at this file. In the settings, we just have all the pre-approval for all this stuff. We have a README that explains what the project is, the tools.json. So we'll go to the mcp.json first and show you what that looks like, but then we have our tools and our graph, which are the two things that we're going to use to actually build with. So let's look at what the files look like. So our .mcp.json, this is the MCP server configuration for the Claude Code project. It's just a normal MCP servers node. We've installed mcpGraph toolkit. Since we've installed it globally, our command is just mcpGraph toolkit, and then the arguments are the graph and the tools. The graph is just going to be an empty graph to start with, just a template. And the tools are going to be the MCP server fetch and file system tools. So these are the tools that are made available to the mcpGraph, not necessarily tools that are made available to Claude itself. I think that's the gist of it. So let's actually see if we can go run the demo. So let's go run Claude in that directory. And then let's start, we'll just verify the MCP server installed so we can see we have the mcpGraph toolkit installed, and that's the only tool that we have installed. And let's see, let's tell it to create an mcpGraph tool to download a URL to a local file in the downloads directory of this project and return the file name and size. Let's see how it works. We're going to watch this whole thing. You can fast forward if you don't want to see all the gory details. Why is it asking me? So it's going to read the skills first. Now it's going to grab all the tools from fetch and file system. It's going to get the details of the ones that it's probably going to want to use. So I was saying before, this will take a couple of minutes. If you want to skip to the end and just see the end, you can, but we're going to watch this whole process. Okay, so it's going to make the downloads directory. The downloads directory already exists. Sometimes it asks if it can make it, sometimes it doesn't. So now it's going to start testing the MCP tools to understand the outputs. It'll do that a few times. All right, now it's going to test some of the data transformation. Got one that didn't work, then it tried tweaked a little bit, got one that did work. Now it's going to build the graph tool. So we've gone kind of out of our way in the agent skills to tell it to pre-test these things that are complicated just because we've noticed it works better that way. It's possible we could remove some of that guidance and maybe it would get better. It would do just fine. Who knows? We'll see. Okay, so it ran the graph tool. So now it's going to actually add it to the graph. And then it'll probably run it again by name in the graph, just to verify that the actual full path works. And it's going to verify the downloads are what they think they should be. Okay, so we're done. That took about 2 minutes. So created a tool called download URL, gave a description, tells it inputs and outputs, explains how it works, and example usage, and tells us it ran a couple of tests. So pretty cool. Let's go look at it and see what it did. So first, let's go look at the graph. This used to be an empty file. Now we have our download URL. There's the description. There's the inputs and output parameters of the MCP server.
Here's all the nodes it made in the graph. So it's got an entry node. It's going to extract the file name. It's going to fetch the URL. It's going to write the file, going to get the file info, format the output, and return. So pretty simple graph, pretty straightforward, and nice and clean. Got it right the first time. Let's go through here and actually look at, now we can see we have this downloads directory that has some files in it. These are the files it got when it was testing. And let's do one other thing. Let's go, now that we have this tool, let's actually go see if we can just use the tool. So we're going to just tell Claude to just use that tool and go get a file and make sure that works. So we're going to say use that tool to download this file. So this is sort of the beauty of it, right? So now he's just going to call that tool by name with those parameters, all the stuff with downloading the file and writing the file is all happening in the graph. So it's not happening in the context of Claude itself. So there you go. It ran it. It got back the file name and the size, gave me the location it's at, kind of summarized what it was. And that's it. And we can go here and see that that file is now downloaded, 5K of that file. And it's the file that we wanted. So, so that's basically the demo. We saw us prompt, give a simple prompt. We saw it go through like a full development cycle, like a developer do to build, reasonably complicated graph to build the tool, and then ran the tool, tested the tool, ran the tool, and then we were able to just go run that tool later because it was installed in our Claude environment. So yeah, the bottom line is mcpGrapToolkit gives agents a high quality development environment for building, deploying, and running our no-code, code mode MCP graphs. And it actually works. You can install it in Claude Code or any agent that supports skills, and you can go build these codes from simple prompts today. You can literally just tell it to go orchestrate a bunch of MCP servers that you give it. It will do that, and then you can run those in your development environment. So you can go get the code. It's installable via npm at mcpGraph, and it's in our TeamSpark GitHub repo at mcpGraph. There's also an mcpGraph UX that does visualization and debugging if you want to play with that. Yeah, anyway, enjoy.